Okay, let's go. Hello everyone, how are we doing? Great to have you all for another webinar here with us. Please let us know in the chat if you can hear us all right, we look okay, we look as pretty as always. Today we've got a very special guest, Igor, right here at the bottom. And we will talk about him in just a second. But in the meantime, hello everybody. Please tell us where you're from and where you're watching us from. And your name, please. I'm reading the chat. I can see people from Turkey, people from Brazil.
People talking about the F1 season already.
Yeah, I can see, yeah. For some reason, Google is translating all of the comments for me. Don't know if it's doing the same for you. India, Germany, Brazil, someone from Greece, Mexico, India. Quite a lot of people here today. Great to see everyone here. Cool. Ready to make a start? Shall we go, Javi?
Yes, we can go.
Right,
let's do it.
Go ahead. Take it away. Thank you everyone for being here. Take it away, Javi.
Yes. Here it is. You want to make a start, Alex?
Yeah, cool. Hello everyone. Welcome to today's webinar on data for motorsport. This is an introduction for the world of data analysis. And while there's obviously an infinite level of complexity that we could go into, there's about 20 years of combined experience here on the floor. We only have 1 hour, so we'll try and be as concise and as efficient as possible. Of course, our flagship course in vehicle dynamics contains many more aspects of performance engineering, and there's obviously no universal methodology. What we say here is our personal opinions. They don't represent any of what our current or previous employers mean or want or say, and we're not affiliated with any F1 team, so please don't sue us. Next, about us, I mean, you probably already know us. Javi and myself, we met working at Red Bull Racing, designing some cool cars for Max Verstappen. And then Javi moved on to Sauber as a performance engineer for Nico Hülkenberg, diving into a lot more of the data and performance, which is what we're doing today. And we have a very special guest, which is Igor, which we have here. He worked for, he's got nearly 10 years of experience in Brazil, as a data analyst. He works at the Porsche Cup. He's going to guide us through the first steps in data analysis, a bit of a different perspective or compared to what F1 might be. And we've got him for an hour, so make the most out of it. Igor, present yourself, tell us a bit about yourself. Take it away.
Sure. Thanks, Alex. Thanks, Javi. First of all, I wanted to say it's a pleasure to be here with you guys. It's an honor being invited to this webinar to show a little bit of my experience and how things are outside of the F1 world. I mean, you guys are the fancy ones. We are the grassroots of the sport, and I think it's a good difference in field of view and how we see things. So I think it will be a good experience for everyone that is watching us. And thank you guys too for being here. I hope to contribute a little bit to what you think about that data analysis and learn a little bit from me. And of course, bring some experience for you guys too.
Thank you very much, Igor. Well, with this, we should be good to make a start. We're going to have a look at introduction to data analysis before we move on to a more practical side of things, where Igor is going to do a fantastic job on guiding us through the data and enlightening us to all that squiggly lines that we see on our softwares. Before we move on, I want to address the question we get all the time, which is how do we become data analysis engineer in motorsport or a race engineer? So I want to make it very clear, data analysis is not a field, but it is an application of knowledge of one field, which is vehicle dynamics. So for me, I want to do data analysis, or I want to learn data analysis. It's like calling yourself a writer because you know how to use Microsoft Word. So this is what we're going to do today. We're going to give an overview on how to use Microsoft Word, but you need to understand that there is a lot of work behind the scenes that needs to happen in order for you to understand and interpret the data that you're looking at, and to know what you're effectively pulling from the car. So this understanding of car physics is essential to know what we're doing and actually improve the car and understand what's happening there. So we need to master vehicle dynamics. So the absolute goal of data analysis or performance engineering in itself is to extract any millisecond of the car while ensuring that the car makes it to the finish line. So what are the main duties in data analysis? As we were saying, the main thing we're doing or we're looking at is we have a lot of sensors, we have a lot of channels, and then it's our duty to translate all these lines, all these screens, all this massive amount of information into actual actionable performance insights. We need to be able to correlate what the driver is telling, what we see on the screen to one direction, or how we can translate that into performance improvements. So then we'll be identifying limiting factors like braking efficiency, throttle usage, application, steering wheel input. So all this, we thought that clear vehicle dynamics knowledge is not going to give us a lot of information. So we need that, right? So this will allow us for comparison between setup, runs, and drivers to guide the optimization and lead the direction to make the car faster or the driver faster in the truck. So what is needed to do that? Vehicle dynamics is needed, is essential in data analysis because we need to interpret every setup change and what happens in the car in terms of grip, balance, and lap time. It will orchestrate all the different departments and performance areas. And as we were saying, only if we understand vehicle dynamics, we will be able to translate this driver feedback and put it into perspective and actually come up with a solution with something that will make my car faster and will be able to optimize it. So this will be critical for making decisions that are informed based on the physics on the car. And without knowing this, you're just looking. We are, yes. I'm here. Yes, we are.
All right, everyone. I think we're back.
Doing it?
So we've had a bit of a problem. Please let us know in the chat if it's all working correctly. We had a bit of an issue. We're sorry, but I think we should be back. I'm just gonna check that we're streaming all right. I think we are.
We are streaming all right.
Cool, amazing. Tally, take it away. Continue.
Yes, apologies guys. It's the first time that this issue happens to us after having streamed a number of webinars. It happens to the best and worst of us, so thank you for bearing with us. Hopefully we should be back. These things sometimes escape our control. As I was saying, vehicle dynamics is essential in data analysis. It's essentially the direction, it's essentially the background and the knowledge you have to interpret the data that you are looking at. And as much as it's impossible to cover it today in 1 hour, we're going to look at we're going to give some touches and some introduction to what it can be done, and we will navigate our first steps with some software analysis tools. So what is data acquisition? What is data acquisitions and what are sensors? What do we use them for? So there are two main objectives of data acquisitions. So we have all heard this sentence: in order to finish first you must finish. So there are two sides of data acquisition analysis. One is to finish the race, and then we need to finish it first. Finish the race means monitoring systems health and reliability, ensuring all the components are within our with our operational windows. Nothing is getting too hot, nothing is getting too much force, nothing is having too much of a stress. Everything is going to is working as intended, and nothing is going to break down. We have several strategies to achieve that and to monitor that. We can have limits, we can have alarms, but this is one part of the job, guys. The second part of the job is, okay, the car is, you're gonna bring the car home. Now you need to bring it home, but you need to bring it first. So this is what it's all about. It's about optimizing lap time. It's about making the car faster. It's about identifying car balance issues, driver limitations, everything that is preventing the car to go faster. How do we do that? We do that by receiving data from the car. How do we receive data from the car? We rely on the process of instrumenting the car with sensors to measure how it behaves mechanically, dynamically, and even thermally. So we put a lot of sensors in our car, and they're going to give us the information we need to take actions on the car. So this is including not only the installation, but also the calibration of the sensors and making sure that they will be working in the appropriate windows, and they will be delivering appropriate results and appropriate data that is useful for us. Only with this data, we can analyze performance, validate setup directions, and actually make the car faster. But we all hear telemetry, we all hear the word telemetry, we all think that data acquisition is all about telemetry, but live telemetry only exists in some categories like F1. Usually, I'm sure Igor can quote me on this one, for the vast majority of categories, the data doesn't go live, so you need to actually run to the car, plug your laptop to the car, to the cable, and try to offload all the data that you have stored during the session. So this telemetry thing is only a type of data acquisition, which means that runs live, and you can make decisions, and you can look at things on the go, right, Igor?
Yeah, it's a very stressing moment. Sometimes you have to do some minor changes at the car or something like that, or you're having a problem. You have to optimize a session, and you have to download the data from the car to investigate everything. And sometimes, a lot of times, the hardware doesn't cooperate, and you have a bit of lag, and sometimes the data come corrupted. It's things that happened. You learn how to deal with it. Yeah, you learn how to deal with it with time and how things work on the pit box. But yeah, it's a concern that you always must have, because we don't have telemetry. You have to download the data from the car and make sure that it will be recorded in the next session. Some kind of devices, you even have to start them, so you have to be very aware of that.
It sounds a bit like our streaming,
yeah, thank you.
With being some delay, not working half of the times, giving us problems.
We good to move on?
Sorry,
Alex?
Yeah, go ahead.
All right, so now let's talk about the different sensors that we have. We're gonna talk about what I consider the key sensors. All right, which are the sensors that are essential, that should be present in all categories, right? So we're gonna have a throttle position sensor, here marked in blue, which is essentially a position sensor that gives the information of the amount of throttle we are using, that goes between 0 and 100%. We're gonna have a brake pressure sensor connected to the braking lines, for the front line and for the rear line. And because remember that in most motorsport application, we have a parallel or H configuration, not a cross line. So we'll have one for the front, one for the rear. So that will give us a read on the pressure that we have on the braking lines, and that can give us information about how our driver is applying the brakes, when he's doing that, if it's too early or too late, the modulation that he does to the corner as he enters the trail braking zone, and the peak force that he builds. It can also help us with understanding the efficiency in braking and identifying any possible car issues, like brakes running too hot, or there is air in the system. No. Then there's going to be the steering wheel angle sensor here in green, which is essentially this little I don't know what to call it actually, Alex. This little hole which is going to be inserted into the steering wheel is going to give us the read on the steering wheel angle at all the time in the truck. So this is one of the most critical sensors. Why? Because it's most of the balance of the car can be read through the steering wheel angle, through the steering, and this is what we need to evaluate balance. So it's going to give us information about the driving steering inputs, if it's using too much because there is maybe some front limitation going on there. If there are corrections needed, then we're going to get information about the rate of the steering wheel angle that we use, and many other very important information. And then we got the GPS, which is it's given us information about the vehicle location, and in many categories, it is used to infer the vehicle speed of the car, where sleep over ground sensors are not present, or we're not doing these maths to, to find the velocity of the wheels and the gears. It gives us the information of the vehicle speed as well. Then there are some nice to have sensors, which in order of priority for me, one is the damper potentiometer. It's essentially, we also call it damper pot or POTI. It's a linear position, linear position sensor, which is going to be mounted either on the spring or damper to give us an indication on how much our elastic elements are moving on deflecting. So we can have a clear read on the health, suspension health, and body movements, oscillation of the body, bottoming, topping out, or even excessive travel. So this is one of the key for me. Of course, this information can be very helpful if we're trying to refine our model and we're doing correlation further on. So this is a must at all the times. Then we're going to have push rod or pull rod string gauges, which is essentially these little, I'm not sure I'm streaming my...
yeah, we can see your mouse fine.
My mouse. I am, yes. So these little gauges, they're measuring the deformation on the metallic element, which is going to be very, very small, but still this deformation by calculated, it's multiplied by a gain is going to result in a force. So all this is going to measure this little deformation. So this sensor is going to measure this little deformation, apply some gains, and infer the force that is working, actually through the element, through the rod. So this force happening here is also critical to understand load transfer under braking, corner acceleration, even wheel loads, right? So essential as well for model correlation. So this is one of the essentials for me as well.
Just an add-on here, Javi, you were saying that the damper position sensors, for example, is something that is a prime sensor for you, but a lot of categories don't even allow us to use them. So we have to reach to another methods of analyzing how the suspensions work. Yeah, we have to get creative. So you can't always rely on every sensor. Most of the times you can't rely on almost any sensors. So you guys have to be aware of that the most sensors you have, the best. The more information you have, the better it will be your guesses, because you will not be guessing. You will be seeing data and making a decision. But most of the times you will be limited by the number of sensors you're using. So like Javi said, strain gauges and damper position sensors, they are a little bit fancy for entry-level racing.
Can you believe, Igor, I will not know what to look at if I didn't have those. I will really not know where to start with,
Yeah, that's the problem when you have a lot of sensors. you don't know how to improvise.
For me, it's always been about, okay, whatever I want to know about the car, it's there. There is a sensor that exists. Otherwise, there is a mathematical calculation that based on other sensors is inferring this channel for me. So it's a very different reality for me. It's something really I'm not used to.
Yeah.
So that's why it's good to have you guys here, is to have you here as well with us.
A zip tie to the damper shaft is a very good damper position sensor.
All right. Then next we got the IMU, or inertial measurement unit, which is one unit we place on the car and it's giving us the lateral accelerations and angular rates of the car, and there are longitudinal acceleration, lateral acceleration, and vertical acceleration, and it will give us also the pitch, the roll, and the yawing velocity of the car. So this is critical for us to understand, again, to derive more sophisticated channels, to understand things like, for example, the understeer oversteer angle that we will talk about in a minute, it's critical for us to understand, to derive information about the tires, as we will need yaw rates, for example, side slips, all that. So this is going to help us a lot to validate and tune our vehicle models. And yeah, essentially we need these accelerations from the car. We use it every time. And next, we're going to move to something a little bit more hands-on, for which I believe you all have received an email and have been instructed on what's going to happen for this half of the seminar, of the webinar. I'm going to pass it to Igor, which as we presented him, he has a fantastic experience in many different categories, and he's going to be a great guy to present this little interactive section of the workshop. So
exactly.
Give it away,
Just
Igor.
before moving on to Igor, if anybody's lost and doesn't know what we're talking about, in the emails we've been sending you for the past couple of hours/days, there's a link to download Motec, which is the tool that we're going to be using today, and there's some sample data that we've got. So make sure you download that in the background if you can, so you can follow along. Igor, take it away.
Okay, thanks Alex, thanks Javi. Well, basically, I just wanted to say to everyone here that cannot download for any reasons, we'll be showing everything we're doing, everything we're talking about, I'll be showing on the screen. So don't be all afraid to lose that much, but if you want the hands-on to do it yourself, make sure you download Motec and all the other files that we sent you, so we can go together in this one, okay? So let's start. The first thing is we look at the main channels here. We will decode a lap together. Basically, I'm presenting to you guys how the signals present themselves. Once you are a little bit more experienced with this, you will know what channel is what just by looking at it. And as we can see here right now, I'm going to present some of them to you. So the first one, of course, here is speed. You can see that because you have a low rate of increase and then it drops very fast because that's the braking zone. So you can see that the straights and the corners are very well marked because of the speed of the car on those moments. The second one is the throttle application. It's basically sometimes you have like two sensors, one for the accelerator itself from the engine, and sometimes from the driver's pedal. In more modern cars, the rate of the pedal is different from the one in the throttle position in the engine. It's important that you always have both of them if they are very different, but with the pedal, it's the better one to coach a driver, for example. But it's another one important because you can see where the driver is coming back to the throttle if it's not slipping a little bit, and it's a primordial sensor. The next one we have here is steering wheel angle. Steering wheel angle gives us a lot of information and a lot of calculation, which is very important for us to know, like Javi already said, the car balance and everything. So steering sensor is a primordial sensor. If you don't have it, you must do something to have a signal for this. The next one here, we start the fancy ones, is a USOS angle. What is a USOS angle? We call it that because
I love this one.
Yeah, it's basically an understeer and oversteer sensor. I call it sensor because it's actually a math channel in which you calculate the theoretical steering input that you need to make a corner. You can do that when you have all the information from the car and the lateral acceleration, the path, the speed, and you can calculate that easily. And you know that you need some amount of steering wheel angle to do that corner. And this channel here will compare what the driver is actually doing with the theoretical steer angle that was required for that corner. So basically what this channel tells you is if the car is understeering or oversteering, because if the driver is inputting more steer angle than needed to that corner, of course the car is sliding the front. He's having to turn more to make the car rotate and enter the corner. If he's inputting less steering wheel angle than the theoretically required, then you know that the car is oversteer because he's not turning and the car is want to turn. So it's a very, very useful tool, this one, and very visual of the balance of the car.
And
And the
one thing
last
I
one
really
here,
like about the Ausos, Igor, is how accurate this thing is, how meaningful, how physically meaningful this is, and how little information you need from the car, how few sensors you need, because as you rewrite the maths and you you only need lateral acceleration, you only need the geometry of your car, velocity, and the actual steering wheel that you are using. And it's a very precise, because you are not essentially inferring a lot of channels. You are not inferring anything. All these things are very easy to measure. It's not like you are trying to infer things that can bring a lot of noise, a lot of drifting angles, like slip angles, or it's not that complex. It's really velocity, lateral acceleration, and steering wheel angle. If you do the maths nicely, which we cover in detail in our detailed course. Of course, we don't have the time to go into detail now, but I really like this. I really like this channel for being physically meaningful, easy to obtain, and accurate. I really like this one.
yeah. Thanks, Javi. It's a very, very useful one when you have to make a split-second decision sometimes to change the setup of the car or something. It really helps. And the last one, as we can see here, is the lateral acceleration. So basically, it's a primary sensor, like we said. Sometimes it's the accelerometer integrated with the GPS. So in one unit, you already have this information. So if you have an accelerometer in the car, you have this one. And one thing that I forgot to tell you guys here is you can see that all of them are basically aligned. They are synced because, of course, we can't analyze any of these channels alone. Everything is based on a context. So you can see here when the speed is dropping, the throttle is not applied.
Excuse me, Igor, I'm going back to you. I think you're working on a delayed one. You can keep going now. Sorry,
Okay.
we're streaming 3 channels at the same time. We're trying to get everybody. You can go on, Igor. They should have the right
Okay.
screen now to talk.
Sorry. So as I was saying, when you look, for example, at the speed, our first channel here, when it drops, we don't have throttle application, of course, because the driver is braking. So if he's braking, he is not using throttle. And once we start to brake, of course, there's a corner coming, so you can see the steering wheel angle starts to move from 0. And of course, the USO's angle starts to show itself because the car is a little bit understeer or oversteer all the time. So when you are in the corner, the USO's channel will move. And of course, we have the build-up of the lateral acceleration. So like I said, everything here is context. You can't look at any of them alone.
To add to you, Igor, we normally want an Ausos that builds up nicely. It doesn't really go, in this case, oversteer is positive in design convention. I'm not saying this is the right one, but we want it to, to go nice and down, nice and understeery, build up that understeer and make it, and, be something controlled. Everything that, when we see all these initial bytes in the entry, which are positive, oversteer, all this instability, they're really hurting the driver, really hurting the performance. It's really, they attack a lot the confidence on the car. And then of course when the driver smashes the throttle, when he starts attacking the rears, the car is sliding, and then it's very easy to again shift the balance to oversteer. So that's why it's changing all the time. In an ideal world, as we said, we want this nice understeer to build up to the middle of the corner. Of course, we don't want this to be excessive, but we don't want all these understeer and oversteer switching all the time, because that's really poor for confidence. All right, so Igor, you want to keep moving on? You want to decode the next slide?
Sure, let's go. So in the next one, we have a little bit more channels. The first one being engine RPM. We can see that the engine RPM have this particular format where it increases and drops a little bit because that's a gear change. That's a really useful thing too, especially when we are comparing two drivers to see if they are using the same gear in the same moment, the same corner. You can use that. Of course, you can create a channel that shows gears. Uh, the second one we have here, once again, speed. We already talked about that. The brake pressure is a very important channel to see if the driver is braking in the correct spot and with the correct shape. Notice that I didn't say pressure, I said shape, because more important than the pressure, it will vary from car to car, from the weight distribution of the car and all that stuff. But the shape of the brake will always be this like a Dorito shape. It's a very powerful hammer on, and then it will releasing because the driver has to enter the corner and he can't divide the work of the tires to turn and to brake at the same time. So you have to make the max of the brakes, try to slow down the car as fast as he can, but once he starts to input the steering wheel, he has to release some brake pressure so the tires can grip, because if he doesn't, he will just go straight. So always look for this Dorito shape. It will change a little bit between cars too because of things that we talk about in the live data, but you must look for this shape. Once again, we have throttle here, the longitudinal acceleration, as the lateral acceleration is important, the longitudinal too. It's another way to check if the driver is doing what he should do and if the car is doing what it should do. And of course, here we have a fancy one that I never worked with, which is brake torques. Javi can talk a little bit more about this one.
For me, Igor, brake torques should always be used, because I mean, brake pressures they only tell you a bit of the story, because after that, down the stream, you got rotors, radius, you got friction of the pads, you got piston sizes of the caliper. So what you see there in bars, it's not actually telling you, the split of the brake pressures front and rear. It's not telling you the actual brake torque split, which is a more dynamic and meaningful thing to look at, because, the car is not being braked by pressure. It is the actual torque and the force that is effective and that has a meaningful effect on vehicle dynamics. That's something that we should be talking now, Igor.
Yeah, for sure. I mean, we can use the pressures. It's a valuable information, of course, but brake torques is what we really, really should look at, like Javi said. Do you want to comment anything else on this one, Javier, or can we follow up to the...
Just that. I've always been happy to look at torques. I've never really understood. I guess, Igor, you can justify to me why you can look at brake pressures if you don't have brake torques. Still useful for you, You have a reference for your driver when you change.
We tend to look at brake pressures because it's mainly the sensor that we have that is easier and is very consistent. So when you go from track to track, you can evaluate the brake
bias. You don't
change
brake setups,
and all
right?
that stuff.
Don't change the rotors. You don't change the pads. So.
Exactly.
Right, so let's move on to the. I'm gonna give it to you. Pass it to you, Igor, to go through Motec now.
Yep. Sure, guys. If you already downloaded Motec, you can skip this first part here. But for you guys that don't, you will access the website from Motec, the /downloads. Download the i2 Pro, the 64-bit or the 32-bit, depending on your operational system. And then you have to install it. It's quite straightforward to install it. You double click it, follow the steps, just the usual next, and conclude the installation. And once you do that, you need the workbook. This is very important. If you don't have the workbook, you won't be able to open the data that we sent you. Together with the data, there is the workbook. It's named Racetrack Dynamics. And after you install Motec, you double click the Racetrack Dynamics file that we sent you, and it will install itself. It will do everything by itself. You don't have to do anything. So install Motec, and then after you install Motec, you double click the Racetrack Dynamics file, and it will put itself in the right place. If you guys have any troubles, please
just a thing to add on
tell us in the
here,
chat.
Igor. Make sure you unzip the folder first. There were some questions about it in the chat. Make sure you unzip the folder to a location, and then from within the folder, you double click on the racetrack dynamics file.
Guys, don't forget that to unzip the files, because they are zipped. There are 3 files in the zip. You have to extract them and then double click the one that I'm telling you guys, the racetrack dynamics one. So when you download it, once you download it, they will be in a zip file. Unzip them, and then you click the double click the racetrack dynamics file. Okay, then it will install itself.
Igor, we lost you.
Nope, he's fine.
Can you hear me?
Okay.
Okay.
Cool.
You want me to?
Okay.
On the chat, please let us know how that is going. You know, is everyone there? Has anybody had an issue? Can we move on? I think Igor, you can go ahead, and I'll monitor the chat in case anyone has any issues.
Okay, so let's go for the Motec screen. There I can show you guys how to proceed. Alex, just the Motec screen now,
Here we go.
please.
Cool. We can see your
Are we
screen now.
streaming?
Igor.
Okay, great. So once you open Motec, this is the first screen you'll see. Once I told you to install the workbook, you guys will have to come here, open workspace. It should be here, named as workshop. So if yours is not here, I would tell you guys to search for it in the documents /Motec/workshop. But if you double click it and you already have, this is very important, you already have to have installed the Motec file, the Motec software. If you did not install the Motec software and you try to install the workbook, it won't do anything, okay? So first install Motec and then install the workbook. Once you do that, once again, open workspace and double click here. I have another session open here, so I will just close the data so I can show you guys, but once it opens, it will be like this. It should open with this face. This is what you guys will see in your screen. So it's a lot of channels here, a lot of graphs, but they will be empty because now we have to pull up the data from the car. This is just the workspace. The workspace is exactly this we are seeing here right now. So to pull up the data, you come here into this open log file, the little folder here with the plus sign, and you go where your data is, where you download the data, where you extract the data from the zip file. And let's start with the one named Barcelona. I can open both of them at the same time, but I will start with only one. So double click it. It will have this plus sign here. It's selected to be added, and you click open. Once you click open, this is what you guys must see. So we have a lot of channels here right now. So let's just check if everyone's following up. So we basically open Motec, open the workbook, and now open the data.
Cool. For anyone that got lost, you can always pause the stream. You can rewind it. You can go back and forwards and then slowly go back to being live. So yeah, I think we're good to move on, Igor.
Yeah, I saw in the chat here some people are saying they're seeing different thing. You can see that we have different tabs here in the top. So maybe you are in a different tab. That's why you are not seeing what I'm seeing. We are in the driver tab right now. This is basically our tab for driver analysis. So let's go briefly through all the channels here so you guys understand what we are seeing. Basically, we have the names of the channels here, but I will go through them with you. So we have engine RPM as our first channel here, the car speed, the green one. Then the next one is DRS position. This already tells us something about the car. So we have DRS position here. The next one we have throttle and brake. They are compiled here. The brake being the red one and the throttle being the blue one, the lightish blue. Next channel we have here is the steering wheel angle. The next one, the pink one, is the car IUSOs, like we said, the understeer oversteer channel, the calculated one. And the last ones here is basically in the same graph we have car longitudinal acceleration, car lateral acceleration, and gear position. As I told you guys, you can see here that gear is like a stair. It has this stair format because gears are only round numbers. We have first, second, third, so it just skips to the next gear. That's why we have this different shape here. And the last one here is aero balance. This aero balance already tells us something about the car, which we will discuss a little bit later. But this is the main channels here in the driver position, in the driver tab. And in the lateral here, in the right, we have brake temperatures. Here, front brake temperatures. Here, we have the rear brake temperatures. You can see here by the name that the red one is front left, the blue one is front right, and so forth for the rear.
And a good thing here, Igor, is that we were able to create our warning signs to make sure. I mean, we could also create alarms, but in this case, we just put an horizontal line, which is a trigger for us to know that we're exceeding the maximum operating temperature of the brakes and that we should take care or action if that happens on the track. You could also have visual alarms, but
that's very, very important, especially when we are doing data analysis during a session or something like that. If you have those reference lines for maximum and minimums for some channels, it helps you to just by a look, taking a look at it, you can see that this point here, for example, the brake temperature went over 1,000 degrees, which is this line that we inputted here. So if it's a vital signal, for example, oil pressure, you have to be careful with those. Vital signs, we always use minimums and maximums, exactly because with one look at it, you already know if there's something wrong or not. Very good catch, Javi. And the last ones here we have basic. Go ahead.
Sorry, Igor, did you comment about the McPal with lateral acceleration? I was answering a little bit in the chat.
Oh, I'm going to talk about them right now.
Right.
Here we have basically McBall. I will explain to you guys what it is. And here we have the lateral and longitudinal acceleration combined. So this is basically all it's an area that the car creates in all accelerations that it went through. So it brakes, it generated a negative acceleration, there will be a dot here. It made a turn, it created lateral acceleration, so we have a dot here for that. And this here is basically what some people like to call the package of performance of the car. The bigger this area is, of course, the more capable your car is because it's making more acceleration. Lateral, longitudinal, it doesn't matter. You want to make this one bigger. The bigger and bigger this is, the more capable your car is. And McBall basically is a calculation between the balance of the car. So you have the grip in the front axle basically and the grip in the rear axle. And with that you can calculate how much of this grip is in the front axle. Here we have the McBall calculated as a ratio for the front axle, for example. So you can see here the most of the grip of the car, like 57% of the grip of the car, it's in the front axle.
It's a little bit counterintuitive, this one, because it seems like a forward number, it goes more grip to the front axle, but it's actually, guys, what we're looking at here is a weight transfer delta, between the front and the total. So it's this ratio which matters. If you follow our course, you will learn about tire load sensitivity and how load transfer is something that kills grip on the on the axle, the overall axle capacity. So more weight transfer promoted to that axle means that the axle is less efficient. So which this is telling us is that a forwards mechanical balance has more weight transfer in the front axle relative to the rear, which means the car is more front limited. So it has more a more capable rear end, so it has more grip in the rear than it has in the front via weight transfer mechanisms. This is a really cool chart because this mech ball is telling us again, it's giving us an indication on the symmetry of the car, whether my car is mechanically in the same place when it goes to the left corners and when it takes the right hand corners. So if I see, if Igor can point that these two arms, that clear two arms that we have one arm that is sitting lower than another arm. In this case, if for example, my right arm is higher than my left arm, it means that, sorry, I'm talking to this camera. It means that effectively my mech ball is forwards when I turn to my lateral acceleration, which imagine it is right hand corners, and it is rearwards when I turn to the left in left hand corners. So what this means is that my mechanical balance is changing depending on the direction that I turn, which is an indication that something is wrong with your suspension system, something is wrong, you have cross weights, which is changing this, which is making this asymmetric mechanical balance. So this is a very good, suspension health check and balance check. Of course, this can be affected. By the track profile. If the track is very warpy, it can somehow affect it, but as a first check, it is really useful. Now, Igor, you want to move on to next tabs?
Sure. The next one here, we have a brake analysis tabs where we have basically the wheel speeds individualized. So this is not car speed, this is the wheel speed from each wheel individually. We have here the brake pressures as the red and the pink one. And here we have the brake temperatures, so basically the same graph we had here in the driver tab, we have here in the brake analysis too. One very interesting one that we have here is the brake pressure per longitudinal acceleration. This is a plot. This is a scatter plot.
Brake efficiency. Mm-hmm.
Which basically is like Javi said, is the brake efficiency we have here in the x-axis, is the longitudinal acceleration, and here we have the brake pressure total. This is a very good diagnostics to see if everything is happening the way it should. For example, if I have a high brake pressure here around 160, I know that I must have 3G of deceleration. If I don't have that, we must check for something, for some problem or anything.
Correct.
Here we have in the tires tab, we have once again combined here in this first graph the car ISOs, the understeer oversteer channel with the front slip and the rear slip. And one thing worth noting here, you can see that the red one is the rear slip and the front one is the front slip angle. And when you look at this ones, you can see that the front is a lot bigger than the rear one. So the car is sliding the front axle a lot more than the rear axle. This means that we have an understeering car, and the uses here is telling us exactly that. In this point that we have this difference, here it is, the car being understeer. Okay. Then we have in the next one here, yaw, which is basically the rotating speed of the car. This is yaw velocity. Yaw is the movement that the car tries to rotate in some axis. Here we have the steering wheel angle too, combined with this one. Those two together gave us a little bit of metrics of how the car is rotating and entering a corner. And once again, we have the AY, the lateral acceleration. And here we have the last one, this very noisy one here, is the one coming from the strain gauges that Javi talked about. So we have the vertical force on the tires, the vertical force on the wheels. This one is a very important one too. Unfortunately, we would do an exercise with this one because it tells a lot for us about ride, about how the tires are contacting the ground, but we don't have enough, I forgot the word right now, but the acquiring speed of our sensor here was not that much, and we are limited to 10 hertz, and the analysis we needed to do was from 10 hertz to 30. So unfortunately, we won't be able to do this, but just to explain a little bit for you guys, very quick here. All these little inputs here is basically the tire bouncing because they are in a very high frequency, and because of that, we can see that this is basically being dictated by the tire. And when we have a bigger movement, like you're seeing here in this blue graph, this is a slower movement, and because of this, you can notice that it is a body movement of the car. And we can analyze this to filter through the sign of this, through the signal of this channels, and it helps us to set the dampers of the car and the springs of the car. But I will not go too deep in this because it's a very deep analysis, just as a curiosity for you guys. The last one we have here is the aero tab. In the aero, once again, we have the car speed. It's always good to compare aero to car speed. The ride height of the car, front axle and rear axle. The FZ in the axle, so the vertical force in the axle. So this is a sum of both tires in that axle. Here in the right, the green one, we have the FZ total. So we can analyze something interesting here, which is our car increases the FZ a lot with speed. This already tells us a lot about the car too. And in the bottom here, basically we have car speed per ride height in the front and car speed per ride height in the rear. You can see that the ride height of the car varies a lot, and it has a lot of hysteresis. You can see that in the same speed, like 200 kilometers an hour here, we have very different ride heights, and that will be in an exercise that we will do. And the last one here is the aero balance. So it basically tells us where the balance of the car related to the downforce it is through speed. So we can see that the car changes its aero balance through the speed range. And this is very important for us to analyze how our car is behaving, and depending on the circuit, how we want this. I think we cover everything, so we can go to the exercises right now. We have prepared 2 exercises with you guys here, so we can try to interpret a little bit of data and not be only looking at these static images. So the first one here is a question for you guys. If you can explain why and can observe a reduction, we can observe a reduction in vertical load in the front wheels in the main braking areas. So as you guys know, when you brake the car, this is the front of the car, you have a weight transfer through the front because our CG is not on the ground, it's a little bit high up. So when we brake the car, we create a component that makes the CG wants to move forward, and because of that, the front of the car dives. It goes closer to the ground. Why are we seeing here that the ride height of the car, the circles here, they are showing us that the ride height is increasing and not decreasing? Can you give us in the circles is the vertical force. The channel above it is the ride height. But why we see an increase in the FZ, but we don't see the car dropping the front? It's coming up. Can you guys explain that?
I'm going to be reading some of the chat for you guys. I can see... Oh, Rafael. Rafael is saying that braking implies lower velocity, thus less aero. I can see Ludwig saying downforce reduces. I can see Pedro saying not braking and using aero to transfer to the back. I can see someone saying braking over a crest. I can see Rohit saying lower aero. Hi Rohit, good to see you again. I can see front wing stalling with someone else by Ansh. Quite a few answers actually.
I think we need to resolve this, Igor. We need to resolve this to give a little bit more time to the other guided exercise which we do all together. Igor, what do you think?
Yep. Okay, so Alex, if you can stream my screen again, I will explain this very quick.
Yep.
To the guys that said that downforce is decreasing, they are correct. I will show you guys why. If we look here, you can see that we are like in 300 kilometers an hour and we brake to like 138 kilometers an hour. So it's a braking zone. Of course, the speed is decreasing. And if we look, try to accompany, try to follow up where the cursor is in this graph here, which is the FZ, the vertical force in the car. Once I go through the brake, it reduces. I think it will be hard for you guys to see, but basically we are coming from this area here to this area here. So of course the downforce is decreasing. But if we look here in the vertical load in the front axle, the blue one, you can see that it increases as we wanted, as we expected, because of the braking, because of the movement of the body of the car. But then it starts to decrease because the downforce starts to become less because of speed. Okay, so this is a curiosity. You can just to see, so you guys can see that you can't trust everything that your eyes are seeing, because of course you got to understand the physics behind it. So we have weight transfer to the front, as you can see here, it increases, but then the speed starts to drop, and of course the car has less downforce. Okay, this is the first exercise we wanted to do with you guys, and the second one is basically to show you guys what a math channel is and how it works. So Alex, yes, thank you.
I'm presenting. It has a little bit of delay.
Yeah.
There it is. There it is.
Okay. So
Talk about wheel lift.
Once again, wheel lift refers to the phenomenon where the inside wheel loses contact with the ground. From a full vehicle performance point of view, this is detrimental. Of course, if your tire is not touching the asphalt, the only thing that makes your car move forward, backwards, or whatever direction you want is not touching the ground, so it can't move. You don't want a wheel lift. So because of that, we want to search for wheel lift. Can you spot any wheel lift in the data? And what channel did you use to look at it? We already have the answer for the channel here in the screen. So if you guys want to look at it in your workbook, we just go to the tires tab, and we will have the vertical forces here. And if you guys can tell me in the chat which wheel we are seeing wheel lift.
I can see a lot of people saying different things in the chat. Front left. I can see. Yeah, most people say front left. Says Sarah. Says Joshi. Says River. Yep, I think pretty much everyone's saying front left.
Pretty much there.
Good.
So we want to go ahead there.
So you can see that the front left is lifting, but let's make it a little bit more easy and visual for us, okay? How do we do that? We will use a math channel to tell us every time the wheel is lifting.
We can go back to the presentation.
Yep.
Alex?
Go ahead.
Very interactive, this workshop. I like it. There it is. This is just some support for Igor. So let's try to come up with a metric to count as a hint the cumulative time of wheel lift that we have across the lap. We have covered math channels, right, Igor? We have built something live, haven't we?
Not yet, Javi.
All right. I will let you guide this then.
Okay. So we, like I said, to be a little bit more easier for us to see that wheel lift, so we don't have to be looking through the data, we will create channels that tells us when the wheel lifts and how much it lifts, for how many times it's lifted. So let's measure first the cumulative of the wheel lift through the lap. To do that, we will create a math channel that counts every time our wheel sees a load less than 10 newtons. Why less than 10? Because 10 is the wheel is already lifting. You can use another number if you judge that is necessary for your car or your situation. But 10 newtons is a good one. So if we come back to Motec, I will show you guys how to create a math channel. So here below component, you have this little square with colored dots. If you leave the mouse in it, you say maths. You can click on that. You can see here that I already have some math channels. But basically what you do is click here on create. So once again, below component, you have this little square, maths, click on it, and then click on create. You give the name for your channel. The first one we'll create is the one that identifies if the wheel is lifting. So we'll call that is front left lifted. This is the name I want to give it. You can give whatever name you want for your channel, and then we click OK. It's saying to me here that I can't create this channel because it already exists. So I will create the is front left lifted 2. Okay, once it's created, we have to create the math for this channel. To create the math for this channel, I select the channel here, is front left lifted 2, and I add an expression. This is the math that the channel will use to calculate it. Once again, I have to give a name for it. So I'll give the same name, is front wheel, front left lifted. It will be unitless because it's just a count. And here I have to put the expression. To count something, I use the function choose. Sorry, it's 2 O's. Yeah, choose. This I'm telling to Motec, every time it sees the condition that I will put here, it will start to make a count. I open a parenthesis, just like I was using Excel or something like that. And I will tell to Motec which channel it should look for. So
sorry, Igor, just to compliment you, I think it's easy for you because you have experience and everything, but for newcomers and people that haven't been exposed to this, maybe it's worth telling them that they have a function list which they can scroll down and see the options that they have to build their own mathematical channels. And and once you are when you click it and you add it to your expression, you should find some function help, which is going to help you with the parameters that you need to put inside your. If you click on choose, for example, there it is. You see all this yellow thing. So that's going to help you to build your expression in case you don't know it by heart, because Igor has done this million times probably in the past. He's already a pro, the guy itself. But you don't need to know it by heart as he does. So you have this little help.
Good observation, Javi. And here it tells you what the function does and how you have to make the structure for it to happen. So as you can see here, for the function choose, it's an expression that if it's true, non-zero, it will return a value. If not, it will return another value. And I will choose those values. So basically here, you can see that we must input the choose function. It's already here. Open a parenthesis and give the condition. The condition, it will be our channel, the FZ. So I come here to this part. All my channels are here. All the channels that I have are here. And I'll just type FZ. So I can find here the FZ from the front left, the vertical force for the front left. I double click it, it appears here. This is not my full condition because I said that I want to know every time that the front left is seen less than 10 newtons. So I will say to them, every time the FZ front left is less than 10,
we're gonna give a little tolerance. We're not going to be very, we're not gonna specify 0 because there's going to, remember that this vertical load is at the tire, which is going to be inferred by strain gauges and math and lateral accelerations and car geometry, like knowing, so we need to, so the total weight transfer is going to be a function of, is going to be divided into unsprung weight transfer, sprung elastic, and sprung geometric. So the only one that we can actually measure is the one from the from the push rod, which we need to, as some of you were saying, we need to multiply by motion ratio. That's going to change as well with wheel travel. So we're inferring a number of things here, and there is compliance, there is a lot of and difficult to control things that are happening in the car. So we're going to give it 10. We're going to give some tolerance because this is not a simulation. This is a real this is real car data, and we also have some margin of uncertainty.
Yeah, thanks Javi for complimenting that. So once again, the choose function says we have to give the condition. We already gave the choose function the condition every time the wheel load is less than 10, and then we give the parameters that it has to go through. If the function is true, I will give it a 1. So every time FZ front left is less than 10, it will count 1, and if it's not the condition, it will count 0. So this is how your expression must look like. Condition, if it's true, and if it's false. Okay? Once I do that, I can click OK, and my first math channel is created. That is front left lifted 2. Now let's plot this one. I can close here my maths. I go right click, add time distance graph. So left click on, we are in the free worksheet, add time distance graph. Group, I have to add a group. The group will be basically the area where the graphs will be plotted. So I add a group, and then I add a channel. The channel is the one that I just created right now. So is front left lifted. It's not showing here the 2, but it should. But let's use this one that was ready. I double click it. It will appear here in group 1, and I can click OK. Once I click OK, now I have a visual representation every time the wheel lifts. You can see here. There's a wheel lift here, there's a wheel lift here, and there's a wheel lift here. Okay, so now let's calculate the air time of this wheel. How long is this wheel being lifted? We will need to create another math channel for this. So once again, let's go to the math channels, below component, click on it, create a new math channel. I will call this one front left air time. Once again, I'll create a 2 just because I already have one here. So once again, math channels, create, give it a name, click OK. Once you have here front left air time, you need to add the expression. What will happen? What this channel will calculate.
So while Igor does this in the background, we're gonna do a quick recap of what we're doing. So first, we're building a first math channel that is going to identify as a Boolean 1 when there is wheel lift and 0 when there is no wheel lift, right? So first we have written this expression, which gives us this Boolean, 1 or 0. So then we have this Boolean that is working, then is triggered when there is vertical force in the tire less than 10 newtons, which is our condition for wheel lift in this case. It can be whatever you want. Now what we're gonna do is, we see these spikes on the data, which is this trigger derived from Igor, and now we're going to integrate this across the lab and see what is the actual cumulative lift time of our wheel if we put it all, if we give a metric. So imagine this is driver is complaining, car balance is wrong, something is wrong. You see there is performance improvement. that you can do. So then you do a setup change and then you go again. And how do you quantify that your airtime has reduced? How do you quantify that now it is bigger or smaller? How do you put a number of that? So now we're going to do an integration across the lap. We're going to give a cumulative time of the amount of time that the wheel is lifted during the lap. So this is what we're gonna do now. So in order to do that, as Igor is doing, the expression that we will need is going to be integrate, right, Igor?
Yes, because as you can see here, integration of data over time. So this function basically does what we want. So we double click it, and once again we have some brief explanation here and how the function works. And I can give it just a condition, and I can have a parameter, a condition, or a parameter, a condition, and a reset value. So I can reset this every lap, for example. So I go to the channel I've just created. I search for it here. So we have here, is front left lifted, which is the Boolean we created. Double click it. And the only thing I need to know is when this one is true, I want to integrate the time that it is true. So I don't need to give it a condition, a reset time, or anything like that. Just this function already tells me all the time that this one is happening. Okay. So with that, I just click OK, and the math channel is created. And once again, we're going to add it here together with the front left lifted. So right click on it, properties. I will create another group, because if I don't create another group and just add the channel here, they will be mixed up, but I want them to be separated. So I will create another group, and in this group too, I will add the channel that I just created. So front left airtime. So front left airtime, I double click it. So now we have in the group 1 is the front left lifted, in the group 2 the front left airtime. Click OK. Then we have both of them, and we can see here we have a cumulative counter of how many time my wheel is not touching the ground. And just as a visual reference for you guys, let's add here too, right click, properties, another group, and I will add here the channel for the front left vertical force, just so we can see that it is counting correctly. So I'll search for the FZ channel, front left FZ, and OK. You can see that it counted exactly where it comes close to 0. Once again, we come very, very close to 0, it counted again. Very, very close to 0, we counted again. But it's very, very easier to look at these two graphs here in the top than this one in the bottom and keep looking for wheel lift. This one is a lot more visual.
So now you can make comparisons between laps. You can compare. Okay, in this one I had 7/10 of wheel lift, and then here I have 3/10 of wheel lift. You have a number at the end of the lap that you can come to and see if to have a quantitative understanding on this phenomenon. Now, thank you very much, Igor, for this for the demonstration. Alex, if you have capacity to please bring up the presentation.
Yep, you've got it now.
Yep, thank you very much. And thanks again, Igor, for this great explanation. Quick recap. We created the is front left lifted with a choose, and then we do just a cumulative time of that with the integrate function, and we end up exactly with what Igor has presented. Thank you very much, Igor. Great job.
Thanks, Javi.
So, Alex, I will give it to you now, actually.
Cool. Actually, Javi, I actually wanted you to give him some words on this one, because at the end of this presentation, we have how data is really one of the things that we're asked, the most about, and it's one of the things that people know less about, right? Like everyone knows what aerodynamics is, but becoming a race engineer or performance engineer, it's a bit more obscure. Wouldn't you say, Javi? Isn't that a thing we hear very often?
Yeah, agreed.
So as such,
and again, it's not about learning how to use Microsoft Word, but knowing how to write a book, right? So learning how to use Microsoft Word doesn't make you a writer. This is what I always say.
Yeah, exactly. And it is one of the most common questions we get. And again, it's one of those where you don't really know what you're doing until you actually do it live or you learn from someone who's done it. It's one of those where it's very difficult to learn. That you can't really learn these kind of skills by reading a book. The same way I'm sure you can learn Navier Stokes by doing that. Which is why we created a new course actually, which is data analysis, a practical guide to a Grand Prix weekend. This is a 4-hour course that's happening on October 17th, and it's a combination of Javi's and Igor's almost 20 years of experience in data analysis and Grand Prix weekends, all packed into a short course. We've made it a shorter course, more accessible. It's a lower price because we really want to get all of those people that struggle to know where to start and to struggle to know where to go. We want to guide you. This is not just about data analysis. It's about understanding how to approach a race theme, the different soft skills that you need, and the pathway through the different track events. And it will be, we'll get off a bit like how we've done in today's webinar, where you ideally want some basic knowledge of vehicle dynamics, but you don't need to be an expert in anything. And this course goes for just 99 euros. However, you can actually get it for free or for 50% off. So between now and the end of the week, this will be included for completely free in all purchases of one of our main online courses. So whether that is the complete guide to aerodynamics in F1 or the complete guide to vehicle dynamics in F1, all of those purchases will come with the data analysis module for completely free. So that's an opportunity. And after that, you can either buy it separately for the 99 euros that we said earlier, or with also any course purchase, it comes at 30% off. You can access it on racetrackdynamics.com/data analysis. So just to bring that home, if you purchase any course before the end of the week, you get the data analysis module for completely free. So good opportunity, don't miss it. For anyone that doesn't know, Complete Guide to Vehicle Dynamics happened on the 25th and 26th of September, so in a little under a month, via Zoom. Condenses Javi's 10 years of experience in vehicle dynamics and performance engineering into just one single module, one single course, suitable for anyone with a high school background in maths and physics. And this course is actually used by certain universities for a master's degree in motorsport engineering. They literally hire us directly to teach the entire subject, and those masters can cost thousands of euros. Specifically, they do. And you can access it with us for just 299 euros. And again, if you do it before the end of the week, you get the bonus data add-on for completely free. So, besides that, Javi, in case anyone's wondering and you don't know already, we cover tire performance, lateral dynamics, weight transfer, suspension design, performance and simulation. You get a one-to-one session with us.
Which we do with some of our own tools.
Yep, our own tools.
Which we do with some of our own tools that you will... Yep.
Go ahead, okay. You get some tools that we've created to do with suspension design for completely free. You get all your slides to keep forever for yourself. We will also give you guidance and resources and books and so on to make you a vehicle dynamics master. Moving on, certificates of completion. You can all get a certificate of completion for attending this webinar. If you scan this QR code, it will take you to our website where you can download your certificate for completely free. And it's completely instantaneous. No more messages in the next 20 minutes. Oh, where is my certificate? Like we had in the past. It should be instantaneous. If you don't receive it immediately or you can't find it, check your spam folder. It goes in there somewhere sometimes. But again, thank you for being here. Feel free to show off your certificate of completion, and if you tag us on social media or LinkedIn or whatever, we will give you a nice comment and say how cool you are for coming to our free webinars. So we've already gone quite a bit of a time, but I think we have a few minutes for questions, Javi?
We do.
Cool. Then
Always
anybody with questions, drop them in the chat. We have a few minutes left, and we'll see what we can do. Any questions both about
So
data, performance, or
I see the
any other things?
I, s- I see the question. How do you calculate the braking torque? What kind of sensors do you need? Well, you can't directly measure the brake torque, but you can infer it. So you will need brake pressure, and you will need a good model of your full braking system. You need the piston size, the calipers. You need to know you need even a good characterization of your brake pads friction versus temperature, and then rotors and so on. So you need to infer it based on the pressure, but you need a good characterization. Of course, and temperature on the pads, you will need that as well. There are scholarships for the vehicle dynamics course. Unfortunately, at the moment, Alex, correct me if I'm wrong, these scholarships only run for the aerodynamics courses?
Exactly. The deadline for applying to our aerodynamics scholarship is actually the end of the month, so the 31st of August. So if you're thinking of applying, make sure you get in there, Lewis, before the end of the month. And yeah, we don't have any scholarships for vehicle dynamics just yet. We're sorry.
I think we have a good question here. It was asked, how often does feedback from the driver affect that data analysis? This is a misconception that most people have, that the data analysis work by itself. Actually, the car is set up for the driver. Correct me if I'm wrong in another level categories or racing series, but at least the ones that I worked on, we set up the car for the driver. It doesn't matter if your car is very, very fast, but the driver can't perform in it. So the first thing, I would say the most important one is to have a good feedback from your driver to know what to do with your car, trying to reach more performance. But yes, the car must be suited to the driver.
Yeah. Good insight, Igor. When is aerodynamics? Aerodynamics 1 is happening on 12th and 13th of September. There is all the information in the website. If you navigate to Racetrack Dynamics, there you will see the courses, the online courses about aerodynamics, vehicle dynamics. Aerodynamics is happening in, again, 12th, 13th of September, if I'm not wrong. But there are scholarships available, so we will be reviewing, now that we have completed all this series of webinars, we'll start reviewing the applications on a rolling basis and start giving you guys feedback on your applications if you made it. 25, 26 September, as in slides, course dates. I believe, let me double check that just to make sure I'm completely right. Yes, 25th and 26th of September is the time for the vehicle dynamics course. That's what's going to happen. Someone was asking about whether Motec is actually used in motorsports. Yes, it is really useful and used in motorsports. It is, however, not, for instance, a software I have been greatly exposed to myself, as the ones we use in Formula One is Atlas most of the time, all the teams. But it is really, Igor can back me up on this one, but it is really largely used, mostly
I've
used.
heard wonderful things about Atlas, right, Javi?
Yeah, great stuff. That's why they call they are no longer part of McLaren Electronics, and now they are from Motion Applied, so they even changed the name. So, Auso Sangal, is it taken from the Neoswald steer car? I am assuming yes, it is. Which still assuming all transfer and your rate and chassis being no, not really. The kinematic steer angle, which you are mentioning, the neutral steer car, you can infer it just with the lateral acceleration and then velocity square if you do the maths. We covered all that in detail in the course, but there is it's all there, so don't need to think about this. Someone asked if they have access to these. Yes, they still have they are still eligible to this data webbing, to this data course on 17th of October, having completed the previous editions with us. Alex?
Yes, that's correct. I forgot to mention.
Sorry.
If you've done any of our courses in the past, any of them, you're also eligible for the 50% discount. So for that, you can just send us an email, and we will generate you a code for that. So yeah, just to remind that, bring it home. Anybody who has done a course with us in the past, or anybody who purchases a future course after the end of this week, can access the data add-on for 50% off. And anybody who purchases a course before the end of the week will get it for completely free.
Another one here is Chemotech being integrated directly with car sensors for real-time analysis. If not, would you recommend? The short answer would be yes, it can, but it's very, 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 very difficult. We are doing something close to it, like receiving the data in real time from the car in Porsche Cup Brazil, but it's been a 3-year job, and just as now we are starting to test it. So it's not something easy. You need transmitters, you need a very, very good internet. We have a dedicated server that travels with the teams and everything. So yeah, you can do it, but it's not easy.
We have another question. What would you guys advise for someone who is about to start a mech and design engineering degree, applied for VD, wants to get into F1 performance engineering? Well, as a Formula One performance engineer, I can tell you need to master vehicle dynamics. So start that journey early, learn as much as you can. There are books. We're trying to give our best. I'm trying to give the resources I wanted, but yeah, every path is different. We're here to help, of course. It's more or less of the same content as Oxford Brookes Master of Motorsport Engineering. Well, I've coursed that master. I've coursed vehicle dynamics in that master, and I am sorry, but I'm not going to speak very well about that since I have the authority to do it because I've done it, and I don't think this is. Of course, it's true that I'm talking about my own course, but I don't think they're comparable. No, I think this will get much more real exposure, real hands-on to what is actually done on the track rather than, and also if you compare both courses in terms of the actual lecture time, I think they are quite similar, and I don't know what's the actual rate of the Oxford Brookes course at the moment, but I reckon 20, 30, some grants at the moment. It's running expensive, right, Alex?
I've just noticed something, Javi. We've got an issue with the certificate where it says the date is the 27th of September, not of August, which we've actually all missed.
Yes.
It's even wrong on the slides here. Don't know if you can see.
Yes, I can see
yes,
this.
We will up-issue them very shortly. Yes, we will correct that, and then you can re-request it, and it will have August. We will do that as soon as possible, and we will send out an email. Apologies about that.
So again, is it possible for someone to enter the field of data analysis? Data analysis is applied to Formula One or motorsport. Again, is not a field. Sorry to break it down. It's all about understanding vehicle dynamics and make decisions on vehicle dynamics looking at data. But there is one thing that should be very clear from what we covered today. Data is not a field. It's just an application of vehicle dynamics. So vehicle dynamics is what you are after. It is completely possible if you come from computer engineering background. I think this programming knowledge and this this computing knowledge that you have acquired is going to get you very far in building your own tools and analysis tools. But we really need to understand what we're trying to do to avoid running in circles. Thank you very much. Every students we had from high school students to Formula One engineers, really all the different colors and flavors of profiles, right, Alex? Joining to our courses, so everybody's welcome. We cover the basics. We go as much as advanced as we can. If concepts are not clear, we go through them again. So we really take everybody by the hand there. RD kinematics. So how do you enroll RD kinematics? You need to request access by accessing the Formula Student Toolkit in our website, and then that will give you you will receive an email with the link to access the RD Kinesolver, which is online and free. I was starting to thinking, September. Thank you very much for the nice words. The recordings there on the Decoding course will be available in case if the one is unable to attend. Igor, surname is Igor Cruz. Will they be available? Usually we run these courses live. We accommodate a request if people are unable to attend that. So please make sure you drop us a line and we can try to, we'll do our best to accommodate your request. We can record it and we can give you a copy, but these copies are not usually publicly open because we encourage people to join live and to have the best of the experience. But we do accommodate all type of requests, all type of requests. How much data analysis I need to learn to, as an aerodynamics, wanted to get in F1? Well, data analysis is completely unrelated to aerodynamics. They're completely two different fields. So depending what you want to specialize, really. Thank you very much. And I think I've covered most of them.
Just one last question that I saw a little bit upper here, but basically he was asking if it was possible to do some data analysis with just GPS. One thing that we will cover in the data course is exactly how to do some grassroots data analysis, and just to illustrate a little bit, with the GPS from a GoPro, I already done karting. So yeah, there are ways. This will be shown in the data course.
Cool. Everybody that's still left here,
right, Alex.
I am updating the certificate right now, so it's correct. You can re-request it from the same link in like 5-10 minutes, and it will have the correct date. Apologies about that. I'm updating it right now.
Right, so we're good to call it a day. Thank you very much, everybody, for joining us, for staying with us, for bearing with us with the technical issues. You can't really be prepared. Sometimes things happen. Telemetry fails even on the track. It will not be the first time it happens. So thank you for having the patience and sticking with us.
Thank you very much, everyone. Have a great day.
Thank you very much.
And it was great.
Thank you.
Yeah.
Thank you for
Thanks
joining.
a lot, guys.
Yo. Igor, say goodbye, and we'll see. You'll see some of them again.
Yeah, thanks, guys. Thanks for the opportunity. It was a great webinar. Thanks everybody in the chat that contributed with questions and everything. Hope to have attended your expectations.
Amazing. Thank you very much, everyone, and please stay in touch. We've got our social media in the last slide, actually, Javi. If anyone wants to join, we produce some cool stuff in there. And Javi, next slide. And
yep.
Yes, drop us a follow, TikTok, Instagram, LinkedIn, and we'll see you guys on the next one. Thank you very much for being here, and bye-bye.
Thank you, guys.